Okay, hello grade 11. Okay guys, so we are back for a session for grade 11 Euclidean geometry. Yeah, the siren has sounded for the grade 11s to come on the live. And we'll be looking at a theorem that says the angle subtended by a chord subtended by a chord of the circle on the same side. The angle subtended by a chord of the circle on the same side of the chord are equal. The angle subtended by a chord of the circle on the same side of the circle of the chord are equal. We call this angles in same seg. Angles in same seg. Repeat, angles in same seg. So I repeat again the statement: the angle subtended by a chord of the circle, okay, on the same side of the chord are equal. So I'm going to give you the diagrammatic representation of this theorem, okay, very shortly. Just give me a sec, I just want to connect this here. The angle subtended by a chord of the circle on the same side of the chord are equal. the angle subtended by a chord of the circle on the same side of the chord are equal. So I don't know if there's any particular questions that people may have about what this theorem is stating here, but hopefully it is clear. Does that imply equal chords or arcs subtend equal angles? Yes, as per the corollary of the theorem, okay? Which a corollary is something that is derived from a main theorem, okay? Yeah, so just before we actually, establish those corollaries, let's just hang on for a sec, so that first and foremost we can establish what this particular theorem says. So the angle subtended by a chord of the circle on the same side of the chord are equal. So if you look at the diagrammatic representation, we usually call this, or we refer to it, you could say in a sense, it's the bow tie, but this bow tie, guys, does not have one of its wings at the center, right? All four are touching the circumference of the circle. That's what differentiates the bow tie of angles at the center is 2 times the angle at the circumference, and the bow tie that relates to this particular theorem. Okay, so the angle, so this is the chord, all right? So what they are saying is the angle subtended by a chord of the circle. So this chord here, chord AB, is subtending which angle? This angle, right? And it's also subtending this angle, right? Let me just use some color here so that maybe you can appreciate what I mean by that. This chord is subtending, see, opposite this chord, this angle, okay? But the very same chord is also subtending this angle. So therefore, this theorem, what is it saying? It's saying the angle subtended by a chord of the circle on the same side, okay, of the chord are equal. So the angles, which angles? These two angles are equal, we say. And the reason we use is angles in same seg. Angles in same seg. Okay, so hopefully we are flowing together and we are of the same understanding where this theorem is concerned. Okay, all right. Angles in same seg. Right. As I had said, this diagram is very different from this one. You see this bow tie? All corners are at the circumference of the circle. So this is angles in the same segment, the same seg. A chord is subtending equal angles at the circumference. So those angles are equal. Whereas this one, for our grade 11 syllabus, this here, there's an arc, all right? It is subtending an angle at the center. The arc is subtending an angle at the circumference. For this bow tie, we know that the angle at the center is twice the angle at the circumference, all right? So that's very important, okay? So please we don't say this angle is equal. We say this angle at the center is twice the angle at the circumference. That means the angle in the center is double. The angle at the circumference is half the angle at the center. So that's very important. Otherwise, these two, they are not equal. But these ones, they are equal. Angles in the same segment are equal. Okay? So I hope we have clarity about that question now. Okay? Yeah. So if there's any other additional questions around this notion, please ask those questions, because it becomes very important for clarity there to be there. So let's just no, Max, no. No, Max. You can look at examples in the exam, right? Please, some of you are jumping onto my session and you have had the privilege of maybe going to a live session somewhere else or watching videos, and you know the basics. People who are joining my session for the first time don't know some of them the basics. So what I'm not going to do here is try and rush a session and try and go to complex problems before ironing out the concept. Okay, so I'm not going to do that. And unfortunately, I'm unapologetic about that, because I am someone that wants to first establish the basics. What I hate, to be honest, is when I do exam questions later on, after having taught basics, and people seem to be unable to apply the basics to those exam questions. Then I have a serious problem, because it means those people did not understand the concept. Okay, so I'm not someone who will do that. I'm not going to jump to exam questions. You can do that. And I'm very happy if you can go ahead and do that. Those who are joining in, like I said, I've been doing a series of these theorems. I started with the first one. I did the theorem independently. We did basic problems. So what we are doing here is we are still in the instilling phase of each theorem. So I'm not going to jump around based on what you want in the moment that you come into my life. I'm sticking to what I'm doing so that I can explain the concept fully. We can understand that concept fully. And when we move on from that concept to something else, that concept has been grasped by all those who wanted to understand that concept. So unfortunately, guys, if you are someone who wants to come and do that, then I would kindly encourage you to go to a live that will allow you that flexibility and liberty. It's not the place. This is not, unfortunately, this is not the place. All right. So yeah, one step at a time. That's what I'm about. Okay. So if we look at this now, so now we are given a basic problem. Okay. And what I want people to do here now is to actually tell me from what they've learned from the concept. Because remember, what did we say? The angle subtended by a chord. By the way, guys, if it's not a chord, it could be a arc. The angle subtended by a arc of the circle on the same side of the particular arc are equal. Okay, so my question then is, what is the value of x? Okay, based on what we have learned here. Remember, I said if this chord subtends angles at the circumference, those angles on the same side of this chord, we say that those angles are equal. All right, that's what we are saying from the theorem. So if we look at this diagram, if this is 30, what is the value of x? So we are all agreeing together that x is equal to 30 degrees. And our reason for saying that is angles in same seg. And we are using the acceptable reasons from the acceptable reason document to actually substantiate what we are saying. Okay, you can check out the acceptable reason document. It actually says angles in the same seg. Very important, that document. You know, you cannot overstate how important that document is. All right. Okay. So far, I hope we are all flowing together. We are speaking the same language. Okay. As I am obviously hoping that we all would. Yeah. And if you guys are hearing me spit some fire today about, yeah, I'm so unapologetic about, yeah, you know, that's something I've become very aware of. Even in school, in my classes, I try very hard to not, if I have learners in my class that are very good and they grasp the concepts very quick, I'm happy for those learners. But I try very hard to not sabotage the other learners that maybe are grasping on things a little bit slow. I try not to sabotage them, because sabotaging them, hey, there goes my class average, you know, there goes my class average. So yes, it's a bit selfish from my side too. I want all my kids to pass, and so I try very hard to go with my slowest learner so that at the end of the day, all may be benefited and have peace and happiness. Okay, let's go. Here's another one. Butterfly wings. We have x, we have y, that's 20, that's 15. What does the grand jury say? What is the value of x? What is the value of y? What is the value of x? What is the value of y? So once again, all right, arc MN subtends an angle at the circumference, that's 20 degrees. The same arc subtends an angle at the circumference, that is x. So what would you say x and 20 degrees, what is the relationship that we see there? Because these angles are both subtended by the same arc at the circumference, we say these angles are, according to the theorem, the angles are actually equal. Pacecraft, there's no parallel lines here. Okay, for those that are joining in, guys, there are no parallel lines. I didn't put any arrows there. Okay, so in this situation, grade 11s, we have a circle, we have an arc MN which is subtending 20 degrees, okay, and then arc MN still is subtending another angle at the circumference which is x. So what is the relationship between the x and the 20 degrees since they are subtended by the same arc at the circumference? We say x is equal to 20 degrees. In other words, this x is equal to this 20 degrees. The reason is angles in same seg. Okay, because I mentioned that it can either be an arc or a chord. It's still, if that arc and that chord subtends an angle at the circumference, then guys, it is angles in the same segment. Okay, so x is equal to 20 degrees, angles in the same segment. What about y? Arc LP. Okay, if you need to turn around the diagram, arc LP, you can see, thank you Nia, arc LP subtends angle N, arc LP also subtends the angle M, which is Y. So what is the relationship between the Y and the 15 degrees? They are both subtended by the same arc. So therefore, what do we say? Y is equal to, you said it, I didn't say it, you said it, I didn't say it. Therefore, Y is equal to 15 degrees, because the Y and the 15 degrees are equal as angles that are subtended by the same what? Arc. Okay? Yeah. So we say angles in same for grade 11. Seg or segment. Okay? Nice. Are we good? Are we slowly but surely getting the swing of things here? I hope we are. 3. Let's look at another diagram. And then A, B, C, 10 degrees, Y, X, E, D. Okay. Now, back to the theorem. Okay. Okay, just hang on. Okay, sorry about that, guys. Just had a bit of an intermission there. Okay, we are back. Okay, so this is the diagram that we now have. Okay, and so we want to look at this diagram so that we don't miss out on the detail that's there, because we remember the theorem, it says the angles subtended by a chord, the angles meaning plural. So we look here, there's a chord ED, and ED is subtending some chords. It's subtending some angles. In other words, this chord is subtending a few angles. So let's identify the angles that this chord is subtending. So we have chord, obviously ED. It's subtending angle A. I'm sure you can see the triangle. That's leading to that subtending. Then the same chord is subtending for this triangle. You can see that? And it's at the circumference that it's subtending. And then the very same one is also subtending for this one. You see? So there are three angles that this chord is subtending. It's subtending angle A, it's subtending angle B, and it's subtending angle C. And fortunately, one of the angles we know, which is angle C. So then what can we say? Because we want the value of X and we want the value of Y. What do we know about a chord? What does it subtend at the circumference? It subtends angles that are equal. Okay, so I go back to the statement: the angles subtended by a chord of the circle at the same side of the chord are equal. Whether it's a chord or an arc, those angles are actually equal. In this case, it was an arc MN. If you think about it, there could be a chord drawn between M and N, which is why we can say that this arc subtends equal angles, and we use the reason angles in the same seg. So guys, what would be the value of X and Y here? What would be the value of X and Y if angle C is 10 degrees? What do my people say? Okay, thank you, Nia. X is equal to Y is equal to 10 degrees. You can just obviously put it all in there. X is equal to Y is equal to 10. And the reason why we say that is angles in same seg. You see, we finished, done. All right, that wasn't too hard. That wasn't too difficult, I hope. Hope that didn't stun us too much. Okay, I don't know if there's any questions from that. Any point of clarity that people need for that? Are we clear? Are we good? 4. All right. I think now I can officially hand over the keys of the following problems to you. Okay, here's another one to do. You guys can attack this one. I'll gladly watch and observe and see and monitor. I don't want to steal your guys' thunder. I want the value of x and y, of course. We are still in that mission of getting values of x and y, no problem. Okay, so the minute people know, let me know in the comment section, or maybe I can have someone as a guest come up and assist me. Let's see, I think Gladys Knight, is it Gladys or okay, excellent is saying angles in the same segment. It's funny, he also says angles in the same segment. I'm guessing you guys are saying angles in the same segment because you see the reason. But what are the values of x? I see the reason, and of course it should be, and I think you guys are spot on, right? So x is equal to what? Okay, I'm sure you guys are seeing which arc is subtending the angle x. It's arc EF. It's subtending angle x. The same arc is subtending angle h. So therefore we say x is equal to 18 degrees. And rightfully, as you have said, you guys have said angles in same seg. Okay, in the same vein, we want y. Arc HG is subtending angle y, and arc HG is subtending angle 22 degrees, which is f. So therefore y is equal to 22 degrees, and rightfully, as you have said, angles in same seg. Okay. No, not in the live. Not in the live, Lucky Power. Not in this live. Okay. Yeah, you are okay. Ask Matt's question unrelated to the topic. Thing is, I won't be able to answer your question as it is unrelated to the topic. That's what I fear. You can contact me in the like maybe you can inbox me, and maybe what I can do is I can actually answer your question maybe at a different time. We can always just arrange that. Okay, just before this session, someone came into the live. Maybe you can type your question, Luki. Then I'll see if maybe after this particular live, I can actually maybe just address your thing, whatever it is. All right. Okay. Okay, Anil, I'm very happy that you remember the other theorem. Okay, so can you please repeat the last time? Spoke Z. All right. We have. Okay, like I said, guys, this is our bow tie. All right. And the theorem that we are looking at is saying the angle subtended by a chord or an arc of the circle of this on the same side of the chord or the arc are equal. So in other words, this here, this arc HG subtends a angle at the circumference, which we refer to as angle E. So that is the Y. Then the same arc is subtending a angle at the circumference, which is F, on the same side. So we refer to these two angles as angles that are equal. Why? Because they are angles that are located in the same segment. Okay, so we say Y is equal to 22 degrees, for instance, angles in the same seg, because that is the reason that we utilize whenever we find angles subtended by the same chord or the same arc that are lying in the same segment. Okay. Then again as well, arc EF subtends this angle at the circumference, and arc EF also subtends this angle at the circumference. So therefore we say x is equal to 18 degrees. The reason is angles in the same segment. Okay, so the seg part means segment. It's just short for segment. And this is from the document, acceptable reasons document. That's why we've shortened it. We write it according to that. Okay. Here's another one. You are welcome, Spoguhle. There. 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 And there. P, Q, R, we have X here, we have 16 there, we have Y there, we have T and S. We want the values of Y and X. R, Q, and P are on the circumference of the circle. So we want the values of Y and X. This is 16 degrees. So what are our thoughts, ladies and gentlemen? Okay, Nia, thank you so much. You can see what Nia is saying there in the comment section, saying Y and X is equal to 16 degrees. Y and X is equal to 16 degrees. Okay, and what's our reason, Nia? Y is equal to X is equal to 16 degrees, rightfully so. Okay, the reason is, Nia is very correct, Dominic, very, very correct. Like not even funny correct, but seriously correct. Okay, you can see most this chord here is subtending which angle? Angle P, which is Y. The same chord is subtending angle what? Q. The same chord TS is subtending angle R. Please take note, guys, when something is subtending an angle at the circumference. You see, TS, the chord, is part of this triangle, and opposite the chord is angle R. TS is also part of triangle TSQ, and opposite that angle is 16 degrees. It's subtending the chord, the angle at the circumference. TS is also part of triangle TSP, and the chord is subtending this angle. That's why we say Y and X and 16 are equal. Therefore, Y is equal to X is equal to 16 degrees, angles in same seg. So that's fine. Y is equal to X is equal to 16 degrees, angles in same seg. Then, what about this one? Okay, what about this one? So I'm sure you can see that there's other things that we are also having in the diagram, okay, apart from what we are actually used to. I'm sure you can see that DE and GF are parallel lines. So that should call to your attention some of the other theorems that we have learned in previous grades, especially grade 8 and 9. All right. This then should assist us in being able to find the value of x. All right. Anyways, what are our thoughts? Yeah, that's fine. Nyagi, when you say can your reason be arc TS subtends equal angles, that's okay. Yeah, they accept that actually arc, if you specify the specific arc subtending equal angles. It's just that, to be honest, for my learners at school, I never encourage them to use that one. I just tell them to use angles in the same seg, just so that they can always be aligned with the exam, whatever. It might be me mistaking things, but let's just quickly before we proceed, I just want to verify. Okay, this is for triangles. Sorry, let's go back a bit. No. Okay, and even here, guess that theorem is not there. Trying to confirm something here. Okay. Okay. Yeah. So yeah, there it is, the angles in the same seg. Oh, it's even there. Okay. Angles in the same seg. All right, so yeah, I forgot that there. But angles subtended by a chord of the circle on the same side of the chord are equal. All right, it's the 1, 2, 3, 4, 5, 6, 7. It's the seventh last row from the bottom. Okay, that's where angles in the same seg as a reason is. Okay. Yeah. So yeah, being the teacher that I am, I usually always say to my learners, just write the reason angles in the same seg, whether it's an arc subtending equal angles. All right, I know your textbooks exercise a bit of liberty, but me, I always bring my learners back to the acceptable reason document, and I say, guys, please. I had another learner, one of my grade 12 learners. He's busy during the holidays. He's doing proportionality theorem and similarity, because my learners, they know during holidays they do self-study, so that when I come back, we just flow in the maths, and we are flowing in something that they are familiar with. I really try and promote independence in my learners, in as much as I'm there for them, and I am there for them, but I try to promote independence and working of oneself, especially in grade 12, because teacher is not going to be there next year at varsity, you see. So yeah, if they can learn that, then that's fine. But guys, yeah, angles in the same seg, let's try as much as possible to use that. Okay. Be very careful, by specifying the angles. Remember, if you want to say this angle is equal to that one, you must say what you mean. right? So in other words, it's that angle. What is it? It's DEG. DEG is that angle, right? And it is equal to 35 degrees, and you're stating that it is equal to 35 degrees. But then when you say that DEG is equal to 35 degrees, you are saying Y alt angles. And what you don't want to forget is stating the lines that are parallel after saying alternate angles. So you are going to say DE is parallel to GF. Very important. Okay, please guys, earlier on I was busy with the grade 9s? No, grade 10s. And we were doing the basic problems from grade 8 and 9. And I know my grade 10s are very frustrated right now because they're like, sir, why don't you just do the complex want to do, all of you, when you come on, you want to do big complex problems. What you don't understand is that when you understand the basic concept first behind, then you apply that concept to simplistic questions. Complex problems stop being complex because the basics will inform the complexity. That's what I wish learners could understand that. But most of you want to skip over the basics like very quickly and you jump for exam questions. I understand the logic behind that. It's because all the people that have gotten very good marks in previous years, they are preaching the message in platforms that, guys, practice past question papers, and they are correct. But practicing past question papers has efficacy when the concept has first been understood and learnt by a learner. When you go to past papers, then past papers become something that can add value to what you have learned. But past papers can become a pain for most people because they don't even know the basics. That's the problem. All right. So please, guys, so I'm busy there with the grade 10s and I'm drilling them with these basic grade 8 and grade 9. And I'm seeing silly mistakes that kids are making there as I'm doing that with them. And some of these silly mistakes have to do with their reasoning. DEG, angle DEG is equal to 35 degrees. A learner says alternate angles and it's finished. No, you need to state alternate angles. Then you need to state the lines that are parallel. So some of them were very thankful earlier on this morning when I was doing that. They were like, oh, sir, I didn't know that. And I'm like, yeah, bro. So please, basics, guys, you update your diagram after finding the answer. Hopefully the answer you have found is correct. You update your diagram accordingly after finding the relevant answer. Then you look at it again. Now you can see, oh, the X and the 35 degrees. What angles are those? So like you said rightfully, some of you, I'm sure, have been able to see that after you find the angles, angle DEG, please guys, DEG. There was another learner earlier on that said they would write 1 here and they wrote 2 maybe here. Guys, we don't do that. When a diagram is given to us, we must use the letters to identify the angle. So for instance, the middle letter for the 3 letters, the middle letter it defines the angle we are talking about. So we can either say this is DEG, angle DEG, or GED, angle GED, right? And convention is important, guys, so please, these are basic things that we need to make sure that we are fine with. Once we know that angle DEG is 35 degrees, what's left now is to just take our paper, because we know we have that liberty of doing that. We look at the diagram once more, and when we look at it, it's like, oh, I see you, arc. Oh, I see you, arc DG subtends this angle at the circumference. The same arc subtends that angle at the circumference. So these 2 angles, what about them? What can we say about X? What can we say about X? Okay, X is equal to 35 degrees. And we say, what's the reason? Angles in the same seg. You see, even me, I've learnt my lesson. Angles in the same seg. K is saying EDF is equal to EOF. G, D, and her reason is corresponding angles. No. Remember, corresponding angles has to do with F shape, and this is what I was teaching my grade 10 learners this morning, and I could see they like, we know this, but some of them, you could see they were appreciating that, hey, Sir is explaining these things we didn't know. F shape, guys, lines must be parallel, top, we are equal. On top of this parallel line, on top of that parallel line, on the same side of the transversal, that's corresponding. Those two angles are equal. Or we say bottom of this parallel line, bottom of this parallel line, we are equal. So it's either top, or it's bottom. That's corresponding. So if you look at what you've said, K, you're saying ED, meaning this angle, F, this angle you are saying is equal to EGF. No. This angle is not equal to that one because of corresponding angles. This angle is equal to that one because of something else. Angles in the same segment. Okay? So please be careful, okay? Very, very careful. Otherwise, you'll be saying the wrong reasons and it will be detrimental to your marks and your health. So let's be careful to note the right things and then state the correct reason. Very key. Very, very key. That okay, are we ready for the next helping? So that problem was it at least a bit, because at least the problems we've been doing, they were nice. They've been very nice and sweet and cute. All right. Okay, here's another one. We have X, we have 92 degrees, we have E, and they are saying this is E1 and E2. We have B, this is B1 and B2. We have C, they have Y there. We have 32 degrees. We have letter D. Okay, take note. Now they are asking us for the value of X and Y. Please take note, guys, that this 1, 2 and this 1, 2 are not angles. They are not like numerical angles, but they are designating the actual. This is E1, this is E2, this is B1, this is B2. So that's 32 degrees there, and that's 92 degrees. And what they want is our X, and they want the Y value. So how are we going to find the X and the Y value for these particular questions? Okay. Nyaki is saying AE is equal to EB, and the thing is, we have not been told that E is the center in this particular question. Okay. E is not the center in actual fact. There's nothing that has been said. The only thing we know is just this diagram, and we are not even told. In fact, E is not, let's just say E is not the center. Okay, E is not the center. What we want here is X, and we want Y. So I can see what people are, I can see what some of you are saying in the comment section. Excellent says we find B to find X. That's what Excellent is saying. He's saying we find B to find X. Okay, B is here. You mean this entire angle, because this is the entire angle B. Okay, Rabelani Savage is saying something about vertical angles. I don't know if there's such a thing as vertical angles. Maybe it's me, but I don't know. B1, Excellent says. Okay, B1. Okay, what is B1, Excellent? Okay, Infinity Bongs says B1 is 32 degrees. Okay, I see there's a teamwork between Bongs and our good friend there. Excellent. So B1 is equal to 32 degrees. Let's see if that could be the truth, if like really and truly it is. If you are saying B1 is equal to 32 degrees and you are saying alternate angles, my question is, where are the lines that are parallel? Could we say that B1 is equal to 32 degrees alternate angles? Is it possible, guys? Is it possible to say B1 is equal to 32 degrees alternate angles? Retro Edit says, can't be, there aren't parallel lines. Thank you. So as soon as I write it, I erase it. Okay, these are things that you need to be aware of. Okay, so you see, this is basic, guys, but already people are, but now people want exam questions. But even in the basics, we are still, there's a bit of Landuka. Now, I hope you guys can see. Okay, we need to do basics. Take it one step at a time. Then we'll see. We'll see. So we can't use alternate angles. That much we have seen. Bongs AB and DC. What about AB and DC? What about them? Someone is saying B1 is equal to 44 degrees. Where did you get that 44 from? Where did we get the 44 from? That's my question. How about we use 360 degrees rule? Okay, there's a lot of things people are saying here. 360 degrees rule. Opposite side, equal sides, equal opposite angles. Buddha yals. Okay, which opposite sides, opposite equal angles? Okay. Retro edits. B1 is equal to 88 minus x minus 88. Okay, a lot of people are saying a lot of things here. Y is equal to 56. How? Okay, guys, can I bring you home a little bit? Okay. Okay, Rabelani is saying E1 is equal to 92 degrees. Now, I am tending to agree with that. If you are saying, Nyagi, I'm not reading your comments, I can't see your comments. Where's your comment? I can't see any comment that you've written. So you are saying I'm not reading your comments, but what did you say? There's nothing that I see here on the comment section. The only thing I see is where you said, say you don't read my comments. Everything else, I can't see anything. You see, now I'm literally scrolling up my comments and I'm checking, where's Nyagi? Where did Nyagi say anything? There's nothing. Nothing. Nothinng, Nyagi. Nothing. I don't see anything that you've said. Okay. Spiwoko Shlem. Yeah, sure. All right, then let's do this, guys. I want to invite, someone come on and join so that I can actually chat to you and you can answer me as to how do I do this. I'm going to ignore everybody now. The only person I'm going to really take into consideration is the person that actually invites him themselves to be a guest. Come, I'm waiting. Invite yourself. I'll accept you. Okay, but here's the thing. Yeah, okay, here is Mfundo, the big guy. Mfundo, can you hear me?
Yeah, I can hear you, sir.
Yeah, let's do this, man. Let's do this. You are here to silence the...
I just got here. I don't even know what you are doing. What are you doing, sir?
Why did you accept my letter? I want someone to come up and do this thing. Okay, let me
What?
to answer this, to unpack for us here. So let Mfundo go. Hello, okay?
Hello.
Let's go, okay. Let's go, okay. I think you are ready. You are ready to give me dish out for us, please.
Say I'm not perfect, but I wanna try.
My leader, I am not perfect myself, so we are one in being imperfect.
Okay. I
Yeah.
think 92 and E1 are equal
Okay. So
because
in
they
other words,
bisect.
so I should say E1 is equal to 92 degrees. Why?
Yeah, because they bisected E. I don't know
They
the reason, but I know it's bisect something. I forgot it.
bisect at okay. Yeah, that I'm finding it hard to understand what you mean by bisect. Okay, the word bisect means to cut into half, right?
Okay, let me try to explain
So,
differently here. Like this line AC
yes,
and
AC.
B and BD, they
Yes,
cut
BD.
at E.
Very good. They do. So they intersect. In other words, they cut each other. Very good. They do.
Yes.
And then you are
So,
saying something about E1 being 92. Why?
why?
Yeah, why? This is grade 8. In grade 8, you learned that if two lines intersect each other, you see my diagram here. If two lines
Yes.
intersect each other, this angle is equal to that one. This one is equal to that one. But why? Why do we say so? We say the reason is
I thought it was bisect. So you said it's not the one.
look at the comment section. People are saying it.
Vertical opposite.
Yes. Vet op angles equal.
Okay, now I know. And
Please,
then
no,
I was
no,
also continuing
know it
and
forever.
saying y plus 92 degrees plus 32 degrees equals to 180 degrees.
Okay, I tend to want to agree with you if you can give me a strong reason why.
Okay, for me, it's isosceles angles.
Okay, once again, how do you know it's an isosceles?
Oh,
Why is
there are
an
no,
isosceles
sorry,
angle?
say there are no, that thing, that signing thing. Sorry, I don't know. Okay, now I don't know
Okay,
the
let's go.
reasoning.
That's fine. Let's go back. What two-dimensional shape is DEC? DEC.
Yes,
DEC is called DEC is called what shape? What is this?
a triangle.
Yes. So if you look in the comment section, what are people saying about a triangle and its angles?
Opposite angles are equal and opposite
No.
side.
No.
What?
What are the people saying? Look at the most recent comment.
Angles on a in a right. Oh, angles in a yeah, sum of 180 degrees.
Yeah, don't you remember that?
I do.
Yeah, well, you need to use it.
I'm learning how to say. I forgot
Sum
the
of
reasons.
angles in triangle, or you could use interior angle triangle, or you could use angle sum in triangle. There's one of three reasons that you can use. Now you must choose one, and you must stick to it now and forevermore. So when you are given a triangle and you can state this very well, this is very good. You've stated this very well, but now it needs to be substantiated by a
Yeah,
good
my
reason.
reasonings. I am
Hey,
still
hey,
learning.
hey. Okay. You must stop learning phase. You must be now, a novice.
I
This,
must know
this,
the maze.
you know what, this that what I'm doing with you now. This is what I was doing with my grade 10s earlier on this morning. And I could see they were irritated. It's like they were burning because they're like, "Sir, when are you going to do? We want to get into the real stuff in grade 10." And I'm like, "No, let's stick to the grade 8 and
The
9."
basics are good.
Huh?
I mean, the basics, Most of us
Yeah.
don't understand.
I'm telling you, and now you are killing yourselves in these higher grades because the basics are not there. Okay, all right. So
Okay.
that's fine. Now we can go
Find
ahead.
why.
We can solve for
Find
y.
why.
I'm sure you can, right?
Don't have my calculator.
Yo, you see, the calculator is also something that people are so relying on. 92 plus 32, comment section. 92 plus 32, we get 124.
Yeah.
Is equal to 180. Transpose the 180. 180 minus 124.
56.
Yes. So thank you guys for helping us find y. Yo, wow.
Yeah.
Yo.
They can find X. I don't know.
They can find x. All right.
Yes.
Let's
I'm giving them a chance.
giving them a chance, eh? I love that. I love that. I love the way you said that. I'm giving them a chance. Okay, let's call them up so that they can come and get their chances.
Hello, sir. Hello. Hello, sir. I cannot hear you, sir.
Oh, you can't hear me because I muted myself.
Yeah, now I hear you.
Okay, sorry about that. Kabelo, snap. You are back. Snap.
Yes.
So what are you here to tell us what the value of x is?
The value of X.
Yeah. Because we found y, thank goodness, after much of a struggle. Now we want the value of x. And we want straight to the point. What is the value of x?
32.
Thank you. Why?
Same segment.
Okay, our reason, angles in the same seg.
Segment.
Thank you. Angles in the same seg. So I'm subscribing, guys, to the acceptable reason as per the document. Angles in the same seg. And maybe some people are wondering, what do you mean angles in the same seg? Look at arc. This is chord BC. It subtends the angle at the circumference, the angle D, and the same chord subtends the angle A, which is X. So those two angles, they are equal. Thank you so much. Kabelo, snap, bro. When you just snap your fingers, you come along and you just sort us out, eh?
This thing is easy, sir. This thing is.
Nah, that's good. I'm glad you know it's easy. But please make sure, because I can sense some tatazelaring when you are writing the reason, Mr. Snap.
The reason. Now they can penetrate me.
Yeah, and what I'm saying is that we need to subscribe to the reasons. Let's use that acceptable reason document to ensure that our reasons uniformly are the ones that, will lead to the beauty, Otherwise, I am glad, Kabelo Snap, that you snap, man. You know your stuff.
Yeah, but it was hard to get there, sir.
Okay, let's move. It's like we are moving. Let's move. We have another problem here. Let's move here. Kabelo, I hope you don't mind. I want to call back K. K, are you still there?
Yes, I'm still there.
Yeah. K, you were able to give Kabelo a chance, and Kabelo was able to really take care of business as a true man. So I want you now to come back. Now we are told O is the center in this problem. and we want to find the value of x. So can you help us out, K, so that we can get that value of x? Yeah.
Okay, so I'm still thinking.
Still thinking? No, that's fine. Yeah, it's good to think. It's a very beautiful thing to think. Now this should be very interesting.
Can I do it, sir?
Okay, just
Yes, you
hang.
can.
Yeah, you can. Please go ahead. Have a blast.
Is it theorem number 2 or 3? Angle at the center is twice the angle at the circumference.
Okay, angle at the center is twice the angle at the circumference. Okay, what made you think of that one, Kabelo Snap? I mean, we are busy with angles in the same segment, and when I hear you are thinking about angle at the center.
You have said that a zero is a center, sir.
Yes, very true. Yeah, very
So
true.
we'll deal with the center second.
Oh, that's beautiful. No, I love that. I love just the simplicity in which you say that. It's very beautiful. You know, it's just that, Kabelo Snap, in as much as you've said what you have said, there are so many people, I'll tell you now, you know, people know about the bow tie, and because they know about the bow tie, everything that has to do with the bow tie, people tend to think that those angles are equal. Doesn't matter the situation, you see. Yeah. So I'm happy that you are mentioning the fact that, no, sir, you mentioned that that angle is at the center. All right. So, of course, arc AB subtends the angle at the center, and it subtends an angle at the circumference as well. But that angle at the center is twice the angle at the circumference. So as you have rightfully said, you said x is equal to what, Mr. Kabelo Snap? X is equal to what, and the reason?
40.
Okay, x is equal to 40. And the reason you said angle at center is equal to 2 times angle at
the angular circumference.
Thank you. You are the main guy. You are the main guy. You are the main guy. All right. Kay and Kabelo, I'm going to say goodbye to you. Thank you so much. It was nice. It was beautiful. You guys are beautiful. Keep it up. Keep it real like that.
Thank you, sir.
Thank you, sir.
Yeah, thank you. Thank you. Thank you. Is it Casa Warrior? Is it Casa Warrior or what? What's the name there?
Hello.
Hello, how are you?
I don't speak English. I'm French.
That's beautiful, but you're speaking nice English there.
Eh?
So how can I help you? Your request?
Yes.
Yes. So how can I help you? How can we help? Okay, I think let my French-speaking sister go there so that I don't put her under undue pressure unnecessarily. Need to be kind. So let's come here. Oh man, okay, I see. Sorry. Hi, but thank you, Focus. I'm happy that people are also fighting my battles for me there in the comment section, because yeah, I know people want tough questions. They want those higher ranked, higher grade questions, and I'm not against those. Don't get me wrong, please. Don't get me wrong. All your people that are in my comment section, don't get me wrong. There's gonna come a time when I will do a lot of those, but for now, that time has not yet arrived. It is needful for now. that I do the basics and the fundamentals. Okay, so let's look at this one. We've got 1, we've got 88 degrees, we've got A, we've got Z, we've got 1 there. So that's the letter Z, it's not 2, okay? But that's 1 and 1, that's 2, that's X, and that's Y. Okay, please, guys, we can request and come on so that we can flex our geometry muscle on the live for all to see. Flexing muscles of geometry is fine. You know, it's no problem there. Okay. Okay, I can see that there are eager people that want to come on. Let's go to Mr. Sean Marcus. Yeah, O is the center, guys. Yeah, in all these problems, O is the center. O is the center. Okay, O is the beautiful center. Mr. Marcus.
Hello.
How's it, Mr. Marcus?
I'm well, thanks.
Hey, what a wonderful name you have, Sean. Yeah.
Yeah, thanks.
Yeah, sir. So I just want someone to come on and just help me out here with my X, my Y, and my Z, because I want them. You see, I'm hungry for them. So let me do you a favor. Let me switch off my comment section so that you can really be alone, so that the glory can all be yours.
Oh, okay. I think X is 44.
Really?
Yeah, according to me, because
Okay. Let's
the way I see it,
it's no problem. X is equal to 44. Reason, my leader.
reason.
Yeah. It's
I
nice
don't
to
know
see.
if I'm correct, but let me try.
Please try. Trying is fine.
So, angle at the center is twice angle at the circumference. Is it correct?
Yeah, angle at center is equal to 2 times angle at circumference. I like what you said there. Right. Just as long as we make sure we write that reason according to the acceptable reasons that we have, that is safe. Okay. Angle at center equal to 2 times angle at circumference. X is equal to 44. So I can be awarded my marks. Statement is correct. Reason 100% correct. I can update my diagram and write in pencil there in the place of X 44 degrees, so that when I look at my diagram again, I look at it with the new information intact. Nice. Thank you. So I will write 44 there. I'm happy with that. Let's move. Okay,
Now
as I said,
now we're looking for Y.
we are looking for anyone, either Y or Z, any of the two. So there's a Z there and there's a Y there. I've switched off the comment section so that no one interferes with you and what you want to say.
Okay. What? I'm not winning. It needs time. It might take time.
Okay, that's fine. It's fine. I think there's someone who wants to come on and assist as well. This one was saying I am not accepting his request. He wants to come up, so let me give Rufio a chance.
Sure.
Okay.
Oh, Rufio, you are here to save the day, Superman.
Yes.
No. Let's save the day, my leader. Let's save.
X plus Y equals 90 degrees.
Ha! Really?
Yes.
You're kidding me. Where do you see that?
Angles in the semicircle.
Angles in a semicircle. Haibo, where's the diameter, my leader? Where's the diameter you're talking about?
angithi O is the center.
Yes.
So the line that passes through the center is and touches both sides of the circle is the
Yeah.
diameter.
Oh.
So AC is the diameter.
Wow. Okay. Yay. All right. So say that again. You said
AC is the diameter. So
yes.
D x plus y equals 90 degrees.
Hey, this guy. X plus y is equal to 90 degrees. The reason you said?
Angles in a semicircle.
Angles in a semicircle. Yeah.
Circle.
Hi, my leader.
Then
You're
you
the
solve
one.
for y.
Okay. So x
Then you
was
solve for
44, right? Plus y is equal to 90. We substitute because we got x. The beauty of updating our diagram after finding x for the previous one. So y is equal to, we transpose. We get an answer of what? Y is equal to?
I don't have a calculator in front of me.
This calculator is always going to stand in our way because our mentality of maths is not mathsing. Okay, no, it's fine. Even though we don't have, yeah. Okay.
And then we're solving for Z.
Okay, so let's update the diagram there. 46 degrees. Why? Yes, we want Z now. Thank you so much for that, by the way, Rufio. Like, just sorry,
X
Rufio.
and P1.
Sorry, Rufio. Sorry, Rufio. I just wanted to say thank you for the previous one. Thank you so much. Like that was really good. The diameter, you see, that's beautiful. Okay, next one, Z.
Z and P1 are equal.
Okay, Z and P1 are equal.
And P1 are equal because of the radius.
Oh, so in other words, initially AO is equal to BO. You are saying?
Yes.
Okay, the radii. And then you are saying Z is equal to B1. Z is equal to B1. Why is Z equal to B1?
And then angles opposite equal sides.
Thank you, my leader. I really appreciate that. Angles opposite equal sides. Okay, then?
And then 180 minus 88 divided by 2.
180 minus 88, you are saying?
Divided by 2.
Oh, so I'm guessing you are taking that from 2Z.
Yes.
Okay. So just for someone, sorry, Mr. Rufio, just before that, for someone who's watching, who may probably be asking, how did he get there? Okay, so Rufio is looking at this triangle now. Remember, Rufio said AO is equal to BO. And the reason why we are saying that is because your radii, okay, we know our radii must are equal. Then he then concluded that angle Z, the Z here is equal to B1. Why? Because angles are opposite these equal sides, AO and BO. Then from there, we can look at this triangle AOB and add the angles of the triangle. They all add up to what? I'm just trying to help that person who's probably looking at this and they're like, I don't understand where that comes from. And your reason, sorry, would have been Z plus
Sum of
80.
angles in a triangle.
Sum of angles in triangle. Right. And get from there, of course, Z plus Z is 2Z. 180 minus 88, we get
92.
Yeah, 92. And then we divide both sides, as he said, by that 2. We get what? What's 92 divided by 2?
46, I think 46.
Thank you, 46. Very true. It is definitely 46. Okay. So, yes, that's a way of getting Z. That is a way that we can use to get Z. I'm hoping other people can see another way of getting z. Immediately after you get your value of x, there is a quick way of getting the angle z after you get y. So after you get y, you can get your z. You guys see the relationship?
Oh, yes, sir. Yes, sir.
Yeah.
Yeah.
Yeah. All right. So you could have also used, after finding y, you could have used angles in the same segment. But this is also fine. I mean, we still get the answer. That's all that matters. As long as we employ the geometry, reasoning, and the approach that's appropriate and that's right for the situation. Okay. Thank you, bro. Aye, Rufio.
sir.
Aye, Rufio, you are burning. You were like fire, my leader. You're like a fire there. You must keep that fire burning. Yeah. Okay. I'm gonna let you guys go. The both of y'all. Mr. Sean, thank you so much as well. You helped me out there with the beginning of that problem. That was phenomenal. Thank you so much, buddy. I hope you learned something there from how Rufio moved through the other problems.
Okay.
Okay, let me restore the comment section so that those people who are burning with comments there can have their comments still commenting. Okay, guys, that was nicely done. All right. And like I said, alternatively, we could have used, for all of this, after finding y, we could have used angles in the same segment to find that other angle. But guys, did you see the way that guy with a few moved from one thing to the other? Yeah. All right. Hi. And I can see you guys are a generation of learners that have used the calculator for everything. I can see that, as opposed to my generation of when I was a student, we used to do a lot of mental maths, a lot of it, finding values using our head, a lot of mental maths that was used there. Okay. So yeah. So with this, from there, we could have just said Z is equal to 46 degrees, angles in same seg. So you'll actually find that some of these theorems can shortcut the process by which we can find something that's missing. So that's why it's important to know the full house of theorems, right from grade 8 and 9, what you learned for lines and angles, triangles, your congruency, your similarity, your midpoint theorem, up to now, the circle theorems. These theorems that you are doing one by one step at a time, you also need to have these theorems as part of your package of tools that you can use when you are doing geometry-related problems. I hope you guys are seeing the value of knowing everything when it comes to these theorems. You forget one thing, guys. One thing that you forget, as far as these theorems are concerned, can really hold you to ransom. It can actually keep you from being able to do a problem quickly and efficiently. So it's important to know the theorems well. So I beg you to make sure that you know these theorems well. Okay, I'm just looking for another one here. Okay, I can't let you guys go, hey? Okay. Yes, thank you so much, guys. Here's another one. Another one to be done. That's 32 degrees. That's x. That's y. And then this angle here is z. And then that's 43. All right. And what they are asking us is x, the z, and the y. All right. So is it feasible and possible for us to be able to unpack? Yeah, I'm willing to accept anyone. Just trying to get different people as well so that we can get variety, guys. I don't want to be constantly getting the same people, but you have to be with someone who's in grade 11 as well. Don't come here, you finished matric long time ago and you just want to flex. Please, guys, don't spoil it. You had your time in the sun. Des.
Yes.
Desmania. How's it, Des?
I'm good, and you?
No, I'm doing well, sir. Are we still within high school, sort of like region, or your university, doing first, second, third year maybe, and you just want to flex some muscles here?
No, I'm in varsity, but I just wanted to revive myself in a little bit.
You wanted to revive yourself.
Yeah.
So how's varsity treating you, man?
It's tough, but we are pushing.
That's beautiful, man. Hey, don't stop pushing, man. Are you first year, second year, third year, fourth, fifth?
No, I'm in my second year this year.
Beautiful, man. And what course are you doing, man? You're an inspiration to these young ones here.
I'm doing meteorology.
Wow. Ish, I need to have you back here on my live. Maybe one day I'll have a chat with people that are at varsity, and maybe you can take us through. It would be beautiful. I'd love that.
No problem. I followed you. I will basically see when you are live.
Awesome. I hope you don't mind, man. I want these kids that are in grade 11 and 12 to sort of like help me with these problems, if it's not a problem, man.
No, it's not a problem. That's why I joined.
Sure, buddy boy. Thanks.
Yeah.
I'm gonna let you go. Like I said, I just want these kids here. Let's see. Why is it that other people can actually come on, but others can't? Yeah, I see the whole under. Chia.
Greetings, sir. How are you?
I am well, and how are you?
I'm good.
Are you ready to take down this problem? Hello.
Can you hear me, sir?
I can hear you very well now. You went silent for a moment there.
I'm sorry for that.
Okay, so I want Z, X, and Y. That's what I want.
Okay. Firstly, I'd like to ask me, is
Sure,
E the
please.
center?
Is E the center? No. E is not the center. It's only O that is the center. So if there was an O, it would have been the center. But no, E is not the center. So thanks for asking that question.
Okay, now the first thing I see,
Yes.
angle A,
Yes.
which is equal to 32 degrees, is also equals to angle E, which is X.
Okay, nice. Did I write two E's? All right, sorry, man. That was supposed to be F. I'm sorry about that. That's confusion.
Yes,
I said EE. Okay, my bad. So you said X is equal to?
X is equals to angle A, is it?
Okay,
32 degrees, yes.
so X is equal to A, which is 32 degrees. Reason?
Angles in same segment.
Okay, awesome. Angles in same seg. In the same seg, sorry. In there. Because there's a there that I usually omit to write. Yes. Okay, then I update the diagram.
Okay, same applies to angle B, which is y. It's also equals to angle D, which is 2.
Okay, angle Y.
Is equals to the angle D, which is 2 degrees.
Sorry. That's Z. It's a letter. Sorry, letter of the
Oh,
alphabet.
Z.
My mistake.
Okay.
Yeah. It looks like 2.
Yeah. So, okay, from here, I know we have to use the 43 degrees angle.
Yes.
How? I
Yes.
don't know.
Definitely.
How? I don't know.
Okay.
But then, all I know is that after using the 43-degree angle, we can also use it to determine the whole full triangle
Okay.
using the 180 degrees.
All right. Okay. You're definitely going somewhere. All right. And maybe I don't know. You see in the comment section, someone is saying something.
Okay. Z is the sum of A and C.
Okay. Can you relate to that? Someone is saying Z, which is, remember, Z is this angle.
Yes.
Is it possible that Z is the sum of A and C?
Yeah, it is. Oh, it is
Why?
an exterior angle of a triangle. Is it?
Yeah.
Maras.
Do you see
Yes.
that?
Now, say, since that is an exterior, okay.
Do you see that though?
Yes. So since it's an exterior, we can add angle A and angle C.
Okay, so let's just trace that out. This triangle has an exterior angle, which is Z.
Yes.
Yeah. So it's always nice when you can actually identify it.
Identify.
Now imagine if someone has forgotten about that particular theorem. Let's just say, for instance, someone has forgotten completely about the whole thing about exterior angle being equal to the sum of interior opposite angles. If someone has forgotten that, then that means you won't consider that, which means you are not going to see that in the diagram. So that means there's other things that possibly we would hope that you are remembering. Okay. All right. So you want to go ahead and tell me what Z is then?
Okay, Z is equals to angle A plus angle C.
Z is equal to angle A plus angle C. Reason?
Which is exterior angles of a triangle. Exterior angle of a
Angle of triangle, yes. Then?
43 degrees plus 32 degrees.
Which is equal to, in total?
Z is equals to 75.
Thank
degrees.
you. Thank you, 75 degrees. Update the diagram. Z is now 75.
75
Then after that?
degrees. Then now that we have 75 degrees, we can go back to the triangle DFE.
Okay, to the triangle. Yes. And then?
DFE. And then you can find the angle E.
Okay.
So that it can help us to find one of the angles at angle A, B, and E.
Okay. So where is Y? Y is this angle.
Yes.
Yeah. And that's what we want.
And also because we have Z now, we can also use the angles in the same segment for Y. Yeah, Y is equals to Z.
So Y is equal to Z, which is equal to 75 degrees.
75 degrees.
The reason?
Angles in same segment.
Okay.
In the same segment.
In the, same seg. Okay. All right, that's done and dusted. We've got X, which is 32. We had the reason. We got Z, which is the exterior angle of triangle ACD. We got that at 75. And then, of course, there's a relationship between the Z and the Y, which is angles in same seg. Okay. Okay, that wasn't too shabby now, was it?
Yeah, it wasn't.
Yeah, I'd say you did pretty good. Thank you so much. That was really nice. Thank you.
Thank you very much, sir.
No, you're welcome. Let's see if we can't let's get someone else up in here. Okay, next diagram. So O is the center there. One ten. We got A, we've got B, we've got R, we've got S, we've got P, we've got C, we've got D, we have Q, we have E there, and then that's T. And we're asked to find A, B, C, D, and E. And we have 20 degrees there. I'm going to zoom this in. So the E is this angle there. Okay, this angle. Okay. So if you're looking at this, the E is there at the center. Okay. And then we have 110 degrees, right? Okay, there's this triangle TQR, there's RTS, there's D there, there's C there, there's O, which is the center. So O here is the center. Okay, just something to note. I will try and draw bigger. Okay, you guys are really driving a hard bargain. You know, almost I'm drawing freehand, guys. Okay, I understand that you want me to draw bigger so that you can see the diagram a bit more, and I understand that. Just please, my apologies. Okay. So I think next time what I'll try and do is I'll try and have these nicely printed out so that I don't have to draw, because my drawings can suck. And I don't want you guys to be exposed to sucky drawings. Okay, so hopefully, yeah, you can have a bit of mercy on me today until further notice, right? S, R, P. It's a good thing you asked me to draw bigger, because I wouldn't have probably subscribed, right? Yeah. Whoever it was that asked. The E is there, so hopefully now we can see it a bit better. TCP. So what you should probably notice is that even in your exam papers, they tend to draw the drawings very big, so that you guys can see. Okay, Mr. Stoji. Okay, so hopefully now we are fine, and we can roll. A, my B is here. Okay, O is there. That is the center. Okay. Right. Let me do the things that I know how to do, which is say goodbye to the comment section, and then I can invite a few people to come up here and razzle dazzle us. Okay, Rachel Shem was asking to join in. Let's see. I saw you, Rachel, earlier on, actually pumping through. Okay, Rachel, are you here to razzle dazzle us with your mathematic prowess?
I'm here to try, sir.
Okay, thank you. That's actually a good thing. We are embracing people that want to try. Put an oomph in your try, you'll be triumphant, eh?
All right.
Okay, let's go.
Okay. Is it possible for AB to be all angles of a triangle? Can I minus the AB from 180, like A plus B plus 110 is equals to 180. Reason being the sum of angles in a triangle.
All
Is
right.
it possible?
Then you're going to have two unknown angles.
Oh yes, and I can't divide by 2 because they're not equal.
Yeah, they are not equal. Very
Okay.
So at the moment, taking that direction needs us to actually have something. It would be nice if we had one of the two, either A or B. Then if we did, it would be nice. And in actual fact, there's information that we have in the diagram that can help us find one of the two, either A or B, specifically A. And what is that? That's the question. What is in the diagram that can help us find the value of A? Because we can state the value of A using the diagram. There's something that we know and a theorem that we can use that can help us.
Angles in the same segment.
Ooh, nice.
Meaning that A is going to be 20 degrees.
Beautifully said. Okay, Rachel, very nice. I'm hoping you see really that, oh, this is chord SR. Subtends that angle. Same chord subtends that angle. So yes, you are 100% spot on. A is equal to 20 degrees. What's the reason you said?
Angles in the same segment.
Thank you. Very well tried. I would say you are putting an oomph in your try. Nice. So we update the angle. A is 20. Okay.
All right. So now we can find angle B using the sum of angles in a triangle.
Nice. Okay.
So we are going to say angle B plus 20 plus 110 is going to be 180. Reason being sum of angles in a triangle.
Okay. Right. Nice. Then?
And then 110 plus 20 is 130. So we're going to say 1B is equals to, okay, all right. Therefore, B is going to be 180 minus 130, which is 50 degrees.
Awesome. B is 50 degrees. Update the diagram. B is 50.
And then we have to find C. Is that C?
E.
All right. C, D, E. Having a hard time here now. Okay, let me see.
I think you were going in that direction, and you were actually. I think there's just maybe something. I think there was something you were seeing this side, and maybe you should still check it out.
Angle S is 90 degrees.
Angle S is 90.
Wait, is PR the diameter of the circle?
PR is the diameter of the circle. Are you asking me or are you telling me?
It's a question, sir.
It's a question. Are you sure?
Yes.
Are you sure you still want to keep it as a question? Do you want to look at the diagram further? We said O. What did we say O is? O is the
center.
Okay, so I'm asking again. Is it a question or are you telling me? What is the diameter?
It's a fact. I think PR is the diameter.
Okay. All right. Then if you think still, then I'm still asking.
Okay, PR is the diameter.
Okay, PR is a diameter. Why do you say the diameter?
because PO is the radius.
True. I agree with you.
Therefore, OR is also the radius.
Very true. I agree with you fully.
And that is going to lead us to the conclusion that PR is the diameter.
Okay, definitely. Yeah, because this is a line that is straight and it passes through the center to the other end of the circumference. So that line that is from one end of the circumference through the center to the other end is called a diameter. True. So I agree with you 100%.
Yes. And so angle S is 90 degrees.
Okay, angle S you are saying is 90 degrees. Okay.
Or C plus D is 90 degrees.
Okay. Why do you say PSR is 90 degrees? It's because you said?
Now that angles in a semicircle.
Thank you. Angles in a semicircle. Don't be scared. You're good. There we go. Yes, PSR is 90 degrees. In other words, you said C plus D is 90.
Yes.
All right. But we don't have C yet, and we don't have D yet. Can we find C or D? What is C?
Is it possible to divide it by 2?
Why? That's my question.
Okay. I'm not sure, sir.
Okay. Can you see something about this angle C? There's something about angle C and angle B.
Oh, yes. Yes. Angle C is equals to angle B.
Why?
Because they are in the same segment.
Okay, that's true. Do you see though, this arc PQ subtends that angle S. The same arc subtends angle
R.
This B.
Angle B, sorry.
Yeah, okay. Not necessarily R. R is the entire angle, but it subtends this angle that's at B. So we can say, therefore, C is equal to B, which is 50 degrees. What's the reason you said?
Angles in the same segment.
Angles in the same segment. So, what more can you tell me? I update my C, it's 50 degrees. D is still waiting.
Therefore, we are going to minus the 50 from the 90.
All right.
That is going to leave us with 40 degrees.
All right.
So
we are using that very statement that we had there because the C was waiting so that we can find D. D is equal to 90 minus 50. D is equal to?
Is equals to 40 degrees.
Thank you, 40 degrees. I update my diagram, 40 degrees. E is
now we have to E.
Yes. This angle. I'm just gonna this one.
All right. E is 2. No. Oh yes, actually. E is 2 times D.
Oh wow. E is 2 times D. Are you sure?
No, angle at the center is 2 times angle at the circumference. Therefore,
okay. So must I write this down? E is equal to, you said?
2 times is equals to half of D, which is 20. Is it?
So you're saying E is half. So angle at the center, you're saying is what? Is equal to?
2 times angle at the circumference.
The angle at the circumference. So E is equal to? 2 times the 40 degrees.
Yes.
Angle at center is equal to 2 times angle at
The
circumference.
circumference.
Yeah. Okay, so E is equal to what exactly then? E is equal to?
E is equals to 80 degrees.
Okay. Sure. All right, that was that. What a meal. All right, good job.
Yes. Okay.
That was nicely done. All right. So you can see, Moss, that you're trying here. You're putting oomphs in your try and you are triumphing. So yeah, let's keep up the momentum, discover what we need to discover, know the theorem so that we can be able to identify and know the diagrams related to each theorem so that you can be able to see, immediately that, oh, that one, there's a relationship there. All right. Remember where you got stuck? Do you remember where you got stuck?
Yes, sir.
Yes. And let that also sort of be a reminder to you, okay, that means that particular theorem, I need to pay a little bit more special attention to it as it relates to certain diagrams. So being able to see the diagram for the theorem is so helpful. I usually say to my learners grade 11 and 12 that it's like taking, I don't know, for instance, if you can make this example, who is your favorite artist at the moment? You like music, right? I'm thinking you do, no doubt.
Yes, I do.
Yeah, so who is your favorite artist? Like you kind of thinking of song that lives rent-free in your mind, heart, and everything.
Ntokozo Mkhize.
Exactly. Now the thing is, I'm sure you know the guy. If I was to take Ntokozo Mkhize and throw him in the midst of 1,000 people, we have aerial view. We are on top of a building. We are looking at the 1,000 people there in the crowd. I give you binoculars and I'm identify Ntokozo Mkhize. If you know Ntokozo Mkhize very well, you'll be able to see Ntokozo Mkhize in the midst of 1,000 people in that crowd.
Yes,
Why?
sir.
Because you know Ntokozo Mkhize, you know how he looks like and so forth. So whether there's many people or not, you'll see him. It's the same thing when it comes to the individual theorems. If you know the diagrams that are related to each theorem and their accompanying reason, you'll be able to see. You see here, you have too many lines and all of that. It's very busy here. But you'll be able to see the theorem, the diagram, the reason. And, that's what makes geometry, in my estimation, quite fun. Because unlike other maths where it's procedures and we know what to do, this one is for once actually allowing us to identify and see. And there's a lot of, it's not just one way to getting to the answer. There's many different ways in which you can get to the answer depending on what you see. So I hope that, you will continue trying. You are doing well. Yeah, keep it up. I'm sure you will munch it up as you go on. Otherwise, thank you so much, Rachel. Hope you have a good one.
Thank you for having me, sir.
Sure. All right. That was actually, I think, the last one, the last problem. What I wanted to do quickly now before I leave you guys in peace, because I'm sure you are so sick and tired of the geometry now. It's like guys, you are now, man, yo. This guy, no, we must go now. All right. I just want to touch on what we refer to as the things that come out of this theorem that we've just looked at. We call them corollaries, all right? These are deductions made from the theorem, angles in the same segment. We can, which papers are you talking about? Second, please give me those papers. Someone is saying, give me those papers. I don't understand. When will you go live for this topic again, sir? Don't know, guys, don't know. I just want to touch on these corollaries. For instance, when I was talking to Rachel here telling me about the favorite artist. The favorite artist will have his band, backup singers, and the likes. Okay. So basically, you could say from the main theorem, you have what you know as the it's called corollaries. They are deductions. Yeah, you can. Yeah, you can. You can compliment Rachel. Sorry, guys. You can definitely compliment. She did a good job. I'm sure even if you can type in the comment section, you can compliment, definitely. Equal chords subtends equal angles at the circumference. So there's this corollary, which is a direct result of angles in the same segment. So if you perchance have two chords, so this, for instance, is chord AB, okay, and then there is chord CD, and these chords, they are equal in length, you know, they are equal in length. We say that equal chords, whenever we have them, they actually subtend equal angles at the circumference. So if you have equal chords, guys, all right, in your diagram, those equal chords will subtend equal angles respectively at the circumference, as long as those chords are what? Are equal. So here we can conclude that angle E is equal to angle F. And we say the reason is equal chords, equal angles. Equal chords, equal angles. This is an important corollary that is used and that we need to know. The second corollary has to do with equal chords. We say equal chords do what? Equal chords subtend equal angles at the center. At the center. Okay, so we're going to look at the diagram that relates to that. Equal chords subtend equal angles at the center. So here is a chord, here is another chord. These chords, they are equal. Then we say, if this is the center, these chords subtend equal angles at the center. So in other words, this angle is equal to that one. Okay, this is not vertically opposite angles, sorry guys, because what would have been nice here is if you can see the diagrams so that you can see this is not, because I think some people will be like, no, this is vertically opposite angles. Okay, I want to draw the diagram slightly different so that you guys can appreciate that no, this can't be a vertically opposite angle. So you can see these chords, this chord and that chord are equal. They have angles that they subtend these chords at the center. We say this angle will be equal to that one. Why? Equal chords, what will they do? The result of having equal chords is that they will subtend equal angles where? At the center. Okay, this is the second corollary that comes as a result of angles in the same segment. Then the third one has to do with equal chords of equal circles. Equal chords of equal circles subtend equal angles at the circumference. Okay, very important. So the two circles, one, no need to be equal circles. That's what's important here. the circles must be identical. Okay, then if you have chords, all right, that are equal for those two respective circles that are the same, then it means they will subtend equal angles at the circumference. So this one has to do with equal chords, equal circles, subtend equal angles at the circumference. These are three important corollaries that you and I need to know for the theorem angles in same segment. You need to know these because I tell you now, there's many problems that you actually find that if you don't know these corollaries, guys, then it becomes a pain because you can't get the angle concerned because you don't know the corollary, right? And the special reason, like I said for this one, equal chords, equal angles. This one says so. Equal chords, equal angles. All right. So yes, you can take a screenshot. Let me just okay. So that's the first one. Equal chords subtend equal angles at the circumference. Okay. CD is a chord, AB is a chord, they are equal. Therefore, we can conclude that because these chords subtend angles respectively at the circumference, we can say these angles are what? Are equal. What's the reason? Equal chords, equal angles. Equal chords, equal angles. Equal chords, equal angles. Then this one. Equal chords subtend equal angles where? At the center. This one was at the circumference. This one is at the center. Equal chords subtend equal angles at the center. All right? This is not vertically opposite angles. It just has to do with the fact that you have equal chords, therefore they subtend equal angles at the center. Then the last one. Equal chords of equal circles. The circles need to be identical. The chords are equal. Then it means that those chords of those equal circles, they subtend equal angles at the circumference. All right. Guys, if these corollaries are known by us additionally, then the learner who is you, has additional ammunition. That literally, like I said, like I said about the main theorem is the main artist that you should be able to know very well so that you can identify in the midst of a crowd. Together with the main artist are the backup singers, the dancers, and all the other important integral members of that particular music group. They are also of importance, but they are back up. You see, so the corollaries are like that. All right, they are like that. Really, I'm doing extra lesson now. You can see most I'm doing extra lesson in a live. So this question of saying, do you do extra lesson? I don't understand it in light of what I'm doing. You can see most I'm doing an extra lesson. This is not a lesson you are getting at school. You are getting it extra. Where? On TikTok. Who would have thought? Me and you, we are crossing paths. Where? On TikTok. Why? Because you have TikTok, I have TikTok. And because of some of the things that I've learned, I've decided to hop on this platform so that I can assist you guys for free. No price paid, except you making sure you have the data to join. So I don't know if I'm we are hearing each other, I'm answering your question, or maybe you feel like, why isn't he being direct? So I'm doing extra lessons, as you can see. Unless I'm missing the point. You're welcome, man. You're welcome. It's my pleasure. It's my pleasure. It's my pleasure. I'm sorry for not drawing the diagram a bit bigger, but here, angle D is 15 degrees, and we are being asked here to find the value of X, which is that angle there. Okay, so I don't know what you guys think. You can see here, there's this triangle BEC. There's an equal chord. It subtends that angle at the circumference. There's that chord NM, which is equal to BC, and it subtends D at the circumference. The numerical value of the angle D is 15 degrees, and they are asking us to find the value of X. Okay, so what will be the value of X here, and why? It's 15, right? Sorry, people, maybe you think I said 50. It's 15 degrees. So X is equal to 15 degrees. Okay, why is it 15, guys? Okay, I see. I hear you, Des. Sorry, man. It's just that I'm trying to put priority on these kids coming on so that I can conversate with them, because they are the ones that are going to be writing. They are in the specific grades. So I hope you understand why it's not that I don't want you to actually answer or anything, but it's that. Then we go to that document, guys. Remember that document that I spoke to you about, the acceptable reason document? That acceptable reason document gives us the reason that we should use consistently whenever we use the reasoning for here. So check me out. I just want to know everything. Yeah, it's not me. Okay, it's not that one. Okay, it's not that one. Yes, it's this one. Now watch me, what? Now watch me, man. Yeah, watch me. Watch me. Now, there it is, guys. So there it is at the bottom. The last 5 lines, last 3 at the bottom. It's there. Equal chords subtend equal angles at the circumference of the circle. So this one, acceptable reason, equal chords, semicolon, equal angles. That is our acceptable reason. Look at the other one. Equal chords subtend equal angles at the center of the circle. Still, what are they saying? Equal chords, semicolon, equal angles. Okay, you can see that they're using the symbol of angles. Okay, then equal chords in equal circles subtend equal angles at the circumference of the circle. You can see it says equal circles, equal chords, equal angles. Equal circles. I hope you can appreciate the reasoning there. Equal circles, equal chords, and lastly, equal angles. So that one we need to include all 3. Equal circles, equal chords, equal angles. Equal chords and equal circles subtend equal angles at the center. Ooh. Do you see that this one introduces the 4th one that was not there in the textbook? Yo, now that is key there. What they've just told us there. All right. So what is this saying in other words? They are saying equal circles, equal chords in equal circles. Hey guys, equal chords in equal circles, equal chords in equal circles subtend equal angles at the center of the circles. That's big. Isn't that big? I hope you see that's very big. Very, very big. Okay, so that's very important. And that introduces us to the other one that's not even in the textbook, or that's not even listed, all right? But what is beautiful about that is the fact that in the New Mind Action Series textbook, which is not the textbook I'm utilizing right now as I'm actually going over these notes. Guys, I'm using Mind Action Series, the old one. Okay. In the new one, I think they've included this last statement, the equal chords. They even have the diagram there. Okay. So I'll be sure to share this with you. All right, definitely. But I hope you guys can see the value of having all of these things available. What? Okay. And that's what I'm using. Acceptable reason document together with the resource to get information, which is my textbook. And then I'm telling you, once I get all the information, and it's solid and I understand it, then what I do then is I go ahead and I go to question papers, and I'm ready for them when I'm done with everything. I'm ready for the question papers. They are ready for me. We are ready for each other. It's a takedown. It's a sweet takedown. So all I did, guys, was I just included the reasons as per the exam guideline for equal chords, semicolon, equal angles. Also equal chords, equal angles. The one that says equal chords subtend equal angles at the center, it's also the same reason. Equal chords, equal angles. Right? Then last but not least, the one that says equal circles, equal chords, equal angles as well. You include three things: circles, chords, and angles. Okay. And then you remember that this same one applies when you have equal circles, equal chords, equal angles, but they are not equal angles at the circumference, but they are equal angles for the same circle or equal circles at the center. That also applies to that. Okay. Yes, all of this will be on YouTube. I will upload it, guys, for your... Definitely, man. I can't not upload this on YouTube because at the end of the day, I know some of you weren't able to join maybe on time, or weren't able to really join when you wanted to. Okay. So what I'm going to do now is I'm going to allow you guys to screenshot this, and then I'm going to love and leave you because, yeah, we did the first one. So all you need to do is B and number 2. That is your game challenge. And then we can call it a night for today, guys. So those B and number 2, you can do those as your game challenge, and we'll call it a night for today. So what we did today was angles in the same segment, and I hope you guys really appreciate that, together with what? Together with the corollaries. The corollaries, I said, guys, I said the main theorem is angles in the same segment, but then the corollaries are like your backup singers. You know, I said main artist most the theorem, and then the backup singers together with the band, they make up the corollaries. There are 4 of them, the 4 corollaries, and we utilize them as well whenever we find them. Okay. Really, hopefully it will be tomorrow. Hopefully it will be tomorrow. Gerardo, you are welcome. That is the whole point, guys. You see, the thing is that is informed by experience of teaching for a number of years. I'm not gonna lie to you. I never used to be that kind of teacher who used to go with the learners. In the beginning, I used to be that kind of teacher who would go with those that are going. If I can see that there's 2 or 3 that are going with me, I will go with them. But then, you know what frustrated me about that was the fact that I saw those learners get high marks, and then I saw the riff-raff, the rest of them, get marks that were not satisfying to my heart. And I was like, no, man, this needs to change. I want to have more learners that get high marks, right, in my classroom. If I'm teaching a class of a certain number of learners, I want to see majority distinctions. You know, it must not be like something foreign to have maybe 60 learners in a class and to have more than half of them get distinctions. It must not be something that is foreign, you know. So that's what informs this thing. Also, the heart of wanting to see all of my learners succeed. How nice it is when all learners succeed. It's such a nice feeling, man. This idea as well of learners getting 90 and above in majority, that's something that I preach so much, you know. But you know what? That thing is attached to understanding the basics, the concepts, the basics. If you understand the basics, guys, there is beauty in understanding basics. You see, when you understand the basics, I don't care, ma. I don't care. You'll see the progress. You'll see the improvement. Changes happen there. So please, guys, yeah, I'll be uploading this video there on YouTube. Those who joined in late, you can catch up on I think this video is more than 2 hours, close to 3. It's very long, but it's meaty, man. Yeah, what I love, it's not just me speaking alone even though yes, at the beginning it was, but it's also interactive. The fact that I had people come up, they interacted, they shared, and they were able to share their responses, and you were able to learn that way. I'm sure some of you really appreciate that, because it gives you a chance to actually see how others are also dealing with the same subject matter, and it makes you feel not alone. So, and this is the whole point. So at the end of the day, we can all do it, man. We can all do it. We can all elevate our marks to something that is way higher than what we actually see it being. So thank you so much, guys. I really appreciated the session. It was very beautiful. It was very beautiful. Have a good night. Take care of yourself. Have a good week. Hopefully I'll have another session tomorrow. That's if everything is able to happen. Hopefully around about same time, 9, but it will be shorter, guys, because I understand it's school night and people have to actually do other things as well. And some of you have curfews, at home, so you need to subscribe to that. YouTube handle, Maths is a Game. It's also Maths is a Game. My in my bio, the link is there for the YouTube channel. There's 2 links. There's a link to the WhatsApp channel, not the WhatsApp channel. You go to the YouTube channel. What is helpful about the WhatsApp channel is that I usually post the update of the lessons I've taught there in the WhatsApp channel. And the clickable link for the YouTube link is clickable on WhatsApp, but it's not clickable on YouTube, the video link, the YouTube video link. So I usually post up the video link on YouTube, on the WhatsApp channel, so that people can be able to click and go to the actual video lesson or the playlist for the Term 2 work. I'm going to upload all the Term 2 work on the playlist for Term 2 Mathematics grade 11. Same thing with grade 10, same thing with grade 9, and so forth. Thank you, guys. Have a good night, and it was very good. Thank you. It was also being nice. It was very nice being with you all as well, our viewer. I think we share the same sentiment. Yeah. Bye, Teapot. Teapot just followed the live creator. Thank you for the follow, guys. Thank you all of you for the follow. Really appreciate it.